All right, welcome back, everybody. Today's lesson is going to be about the distance formula. I'm Mr. Jovanelly with Agua Fria High School. This is distance learning, distance formula. I swear I didn't plan that. All right, our essential question. How can we calculate the distance between 2 points on a coordinate plane? So what we're getting into here is a new unit on coordinate geometry. So we're going to do a lot of things to algebraically prove or disprove geometric relationships. That's what we're going to get to eventually. You might notice here at the end of this standard, proving whether specific points lie in a circle. We actually did that in our last unit. So we don't have to do that part, but we're going to do the rest of this standard. Make sure you're still using Desmos. A lot of you are being very successful with the way you're using Desmos, so keep that up. All right, I want to introduce this idea through this warm-up problem here. So quadrilateral ABCD appears to be a rectangle. Keyword there, appears. What we want to think through is what qualities would we need to prove to know for sure? So I want to get you thinking already here at the beginning is like, what would make this a rectangle? What do rectangles all have? Well, we know that it should have four 90-degree angles, right? Four 90-degree angles. We know that opposite sides are parallel in a rectangle. We also know that opposite sides are congruent in a rectangle. So these are the things we would all eventually have to be able to prove to make certain that this is a rectangle. Today we're just going to focus on proving that opposite sides are congruent. We're going to learn how to actually prove the distance of lines on a coordinate plane. And the way we're going to do this is through something called the distance formula. So let's introduce it by showing an example here. So let's say we were asked to find the distance between point A and B on this coordinate plane. It's the line that you see in red here. Now you notice that point A, they didn't give us the coordinate, but they just called it an x1 value and a y1 value. So just x1, y1. But we can see that if we count it, 1, 2, 3, 1, 2. So A is located at 3, 2. Similarly, point B, it's the x2 value, the y2 value. Now, important here, this is not saying x squared and y squared. This is just saying x2 and y2. So it's just saying the second x and the second y value, not squaring. That's important. Okay, but the b value, if we count that one out, 4, 5, 6, it's 6 as its x coordinate, and then up 1, 2, 3, 4, 5, 6. So 6, 6. All right. So we want to find the distance between these two lines. Now you could probably already see a similar idea here is if you make a right triangle, you can count the distances between the x coordinates and the y coordinates. So if we subtract the x2 value from the x1 value down here, so basically we're finding the length of AC, that would be like subtracting the x2 value was 6. So it'd be like 6 minus 3. And that would be 3. And then if we do the same thing for the y values, the y2 value was 6 as well. So if we do 6 minus the y1 value, 2, we get 4. So in other words, what we just showed here is that the distance of this leg of that triangle is 4, and the distance of that leg is 3. Okay, you might already kind of see the next move here, right? If we have that in our pocket, if we know that this is 4 and this is 3, well then to find the distance of A to B, we could just use Pythagorean theorem. So we could say 4 squared plus 3 squared equals D squared. And we'll just call it D because that's what it was labeled as. So we'll have 16 plus 9 equals D squared, 25 equals D squared. And to figure out the length of D, we'll take the square root of both sides. So the distance is going to be 5 units. Okay, now that may all seem very familiar. That's just using Pythagorean theorem. Now that works great if you have a visual, if you have the numbers on a coordinate plane, if the numbers aren't too large. What we want to do is, what if we could write an equation that would always help us find the distance between any two coordinates, any two x1, y1, and x2, y2. So let's just think about what we did, but let's not use the actual numbers of the lengths. Let's just use the coordinates. So thinking about Pythagorean theorem, we would be able to say d squared equals x2 minus x1 squared plus y2 minus y1 squared. Okay, if you'll notice here, what I've written is basically the Pythagorean theorem. This is my c squared value, this is my a squared, this is my b squared. So I've written the Pythagorean theorem just in terms of these coordinates rather than in terms of the actual numbers, right? But it would be easier if we just get the d variable by itself, right? So think about what we could do here. If we want to get d by itself, it's d squared. If we take the square root, we would then have to take the square root of this entire thing. And then that 2 is included in there. So our distance of any 2 points could be calculated as the square root of the difference in the x value squared plus the difference in the y value squared. All right, all under one big radical. So this would be a good thing to add to your notes here. Some of you were looking for more like specific recommendations on that kind of thing. So here, add this to your notes. This is the distance formula. The distance can be found by taking the square root of x2 minus x1 squared plus y2 minus y1 squared. And then just for your knowledge for the concept, this is just another version of the Pythagorean theorem. It's just written in terms of coordinates. Pythagorean theorem is kind of an amazing theorem. It just keeps showing up in all these places. We saw it in circles, we've seen it in right triangles. It has such wide versatility. All right, let's practice. Let's say we wanted to find the length of BE with B located at -1, 5 and 3, 1. Now notice we have no picture here. So let's use the distance formula so we can get to the answer quickly. One recommendation I have, especially as you start out, is it might help you if you immediately label these coordinates as x1, y1, and x2, y2, just to remind yourself, like, this is my first coordinate, and then this other one is my second coordinate. Okay, if the distance formula is x2 minus x1 squared plus y2 minus y1 squared, we can just start plugging those numbers in. What's important is just to be very careful about negatives and to make sure everything stays inside the radical. So here we go. x2 is 3 minus x1, which is -1, and I'm going to square it. y2 is 1 minus 5, and I'm going to square that as well. And now it's just a matter of me simplifying my math here. So 3 minus -1, that's plus, so 4 squared, plus 1 minus 5, that's -4 squared. Okay? Again, notice how I use those parentheses. It's important that we keep everything in our parentheses. Okay, so here we are now. We know that 4 squared is going to be 16, and then we also know that -4 squared is going to be 16. One quick hint here, we should always get positive numbers. Always, always positive numbers. Okay, so here we go. That's going to be the square root of 32, because we can add them up, and then if we use what we know about simplifying radicals, you can break that down into square root of 16 times the square root of 2, which is 4 times the square root of 2. Okay, I actually pulled that last problem from this picture here. So we've already solved for the length of BE. It was the square root of 32 when we did the distance formula, but we simplified it to 4 times the square root of 2, right? Now what I want you to do is I want you to pause the video here and see if you can find the distance between ED, DC, and CB. So pause it here. Okay, the answers that you should have got, ED is going to be, once you plug in the distance formula, the square root of 20, which simplifies to 2 times the square root of 5, right? Because you could do the square root of 4 times the square root of 5, so you get 2 times the square root of 5. And then you should have noticed that DC was actually the same value. You had the square root of 20 again, which is 2 square root of 5. And then CB was going to be the same value as BE. It should have been the square root of 32, which equals 4 times the square root of 2. If you didn't get those answers, you probably made a small math error somewhere. You probably forgot a negative or squared incorrectly. So go back and check your work there if you didn't get those answers. But you'll notice that these two should be the same because those lines have the exact same dimensions, and then these two lines should also be the same. Okay, when we know things like that, we can answer questions like, what's the perimeter? So writing down our answers again, BE and CB, those were both 4 square root of 2. And then ED and DC were both 2 square root of 5. So if we were going to add all those numbers up, 4 square root of 2 plus 4 square root of 2 plus 2 square root of 5 plus 2 square root of 5. Remember, we can add when the radicands are in common, so this could be 8 square root of 2 plus 4 square root of 5, and that is the most simplified version of that we could possibly get. And if you did want to put that in a calculator, it would be approximately, we could say it's about 20.26. All right, some of you might have been wondering from the last problem, like once you got the picture, why don't we always just graph it and use the Pythagorean theorem? Like why even use the distance formula at all? So the thing I want to end with is the distance formula is useful when you have a situation like the one you see here, where our numbers, our points are pretty far apart, the numbers are pretty large. So we don't want to rely on just graphing it all the time. We'd have to count like a large distance between these numbers, and that's not very efficient. So instead, let's just apply the distance formula. So I'm labeling my x1, y1, my x2, y2, and now I'm going to do the distance of x2 minus x1, so that's going to be 101 minus negative 3 squared plus negative 71 minus 8 squared. So as you can see, our numbers got pretty large. 101 minus negative 3, that's a plus, so we have 104 squared plus negative 71 minus 8 is negative 79 squared. Okay. All right, we're going to use our calculator here. So squaring 104, that's going to give us 10,816. Squaring negative 79 is going to give us 6,241. All right, so adding those together, we get 17,057. So the distance between these points is approximately, so we want to round it since it's such a big number, is approximately 130.6 units. So that's why we want to have the distance formula in our pocket as well. We can find the distance between any 2 points no matter how far apart they are. Okay, these next things are optional. Some of you have asked for extra practice opportunities. So there are 7 practice problems on Khan Academy linked on Google Classroom for you if you'd like. If you're more of like a verbal person, a written explanation, if you just Google the distance formula and then Purple Math as a website that could get you some extra resources there. And then now you can do the exit ticket. Hit me up if you have any questions. Thanks, guys.